This is Cal. Topic 3, homework problems 14 and 24. Here we want to take a derivative of this function. So this will be y equals, we're going to convert all this into exponentials. So this will be x to the 1/2 plus 5. This will be x to the 1/2. And this will be 7x to the negative second power. Alright, now that all terms have been given exponentials, we can go ahead and take the derivative of this now. Now, these are two functions that are multiplying, and when we take the derivative of two functions that multiply, we use the product rule. So this will be x to the 1/2 plus 5 derivative times x to the 1/2 plus 7x to the negative second power plus x to the 1/2 power plus 5 times x to the 1/2 power plus 7x to the negative second power derivative. Okay. Now from here, I want to take the derivative of this function, which will be 1/2 x, and the power will be 1/2 minus 1, which is -1. And then the derivative of 5 is 0. And this is x to the 1/2 power plus 7x to the negative second power. And plus x to the 1/2 power plus 5. This remains unchanged. And this will be 1/2 times x, and then 1/2 minus 1 gives us -1/2. -2 times 7 gives us -14. And -2 minus 1 gives us a -3 power. Right, now we're going to clean up all the exponents. And here we'll have a rational. The 1 will be in the numerator, the 2 will be in the denominator, and the x, because of the negative here, will be in the denominator. Then we'll convert the half to a root. The half here gets converted to a root. And here, the 7 will be in the numerator, but the x, because of the negative here, will be in the denominator to the second power. Okay, let's keep going. This x converts, this 1/2 converts to a root, plus 5. And here, we're going to have the 1 as a numerator, the 2 will be in the denominator, and the x, because of the negative exponent, will be in the denominator. The half will convert to a root. Okay, and the last piece, this 14 here will be a numerator. The x here, because of the negative here, will be a denominator, raised to the third power. Now, on the next one, Dorothy Wagner is currently selling 68 I Love t-shirts, calculus t-shirts, per day, but sales are dropping at a rate of about 3 per day. She is currently charging $7 per t-shirt, but to compensate for dwindling sales, she is increasing the unit price by $1 per day. Question: how fast within and in what direction is her daily revenue currently changing? Well, one thing they're really missing here is that when they say daily revenue changing, what we're talking about basically is the first, without the day changing, or current. That means that time is going to be 0. They really left this out. This really needed to be explained, rather than us picking up that currently implies the time is 0. Okay, so now let's begin with this big correction. Alright, since we're looking for revenue, revenue is made out of price times demand. And the how fast means that we will eventually need to find the derivative of the revenue. Okay, and then once we find the derivative of the revenue, we can put in 0 and get the current change. So first, what's the price? Price right now is being made out of, she's currently selling these things at $7, so the price right now is $7. But she is increasing the price $1 per day, so that's time. So each day that goes by, it goes up another $1. So that's 7 plus 1 times t, the time or day. Now demand. The demand, they have 60 t-shirts, so they have 60 altogether. Now what's happening is that the sales are dropping at 3 per day. So that's -3 each day, or t. So now we have a function that represents price and a function that represents demand. So let's write revenue equals price, which is 7 plus 1t, and demand, which is 60 minus 3t, and we want the derivative of this, so this will be r prime equals 7 plus t derivative times 60 minus 3t plus, I'm using chain rule, product rule here, and this will be 7 plus t times 60 minus 3t derivative. Alright, now the derivative of the 7 plus t, this will all be 1. Derivative of 7 is 0, derivative of t is 1. The derivative of the 60 minus 3t will be minus 3. So what we have is a 1 times this, which is 60 minus 3t, and a negative 3 times both of these, which is a negative 21 minus 3t. Okay, so we put all this together, we get r prime of t equals, let's see here, this will be 39 minus 6t. And now we'll put in our r of 0 for the current time, and we end up with 39, and that's positive. So how fast is it increasing currently? About 39 t's per day. Oh, sorry, how fast is the revenue? So $39 per day.